Hello viewers, welcome to EduHub YouTube channel, bringing you IGCSE Computer Science questions and answers for February-March 2022. Well, before you continue with this video, I would recommend that you kindly subscribe and click on the notification bell so that you will always be updated whenever resourceful videos like this are uploaded to our channel. Alright, so that's by the way. We hope to be uploading videos on problem solving regarding this February-March question 2022, and aside that, we shall be uploading tips on how to answer questions and problem solving and different other questions, just like a variety of questions and problem solving. Alright, that's by the way. Before without wasting much time, we are going to begin with the first question. The questions we are answering in this video relate to February-March IGCSE examination for computer science, and we are working on paper 1 theory. The first question here reads: a computer stores data in binary form. Binary numbers can be represented as denary numbers. A. Converts the 8-bit binary number 01010101 to denary. Okay, and B. Converts the binary number 11000000 to hexadecimal. And C. Converts the hexadecimal number 1A to denary. And finally D. Binary numbers can be stored as bytes. State how many bits are in 2 bytes. Okay, so we take them bit by bit, beginning with the first question on A. Alright, so I have actually answered all those questions, so I'll walk you through how I got to the answers here. Alright, for the first question, we've been given a value, and the value is this. Okay, and we have to convert to denary. Alright, so here you can observe that I have a kind of a table that has 2 rows. Okay, and the first row has to do with the place values of the number 2, because binary means 2 numbers, 2 constants, which are 0 or 1. Alright, so we began with 2 raised to power 0 here, which gives us 1. 2 raised to power 1 is 2. 2 raised to power 2 is 4. 2 raised to power 3 is 8. 2 raised to power 4 is 16. 2 raised to power 5 is 32. 2 raised to power 6 is 64. 2 raised to power 7 is 128. Okay, so why did I do this? The essence of making use of these place values is to be able to know how to place the zeros and ones that I was given. Okay, so and I'm going to start the placement from right to left. I repeat, the placement must always start from right to left. So a different way to be able to place these values for the first row would be you start with 1 from the rightmost, and you proceed to doubling it, which is 2 times 1 is 2, and this one is 2 times itself is 4, 2 times 4 is 8, 2 times 8 is 16, and so on and so forth. So it's just a kind of a different way of navigating through this. All right, so and now, having placed our values, the values that we are given in the question, as you can see here, okay, so having placed the values from right to left, then the next thing we are going to do, we are going to identify from the first row where we have a 1 corresponding on the second row. Okay, so now we have we'll begin from left to right. Okay, because that's how typically most people have to start writing whatever. So from here we have 64 is on. It has a high voltage, which is 1. So in that case, I'm going to write out 64. All right, 32 doesn't have, 16 has, then it's written here. 8 doesn't have, 4 has, and it's written here. 2 doesn't have, 1 has, then it's written here. Adding all of these numbers together gives us 85. All right, so this is actually a very simple one though. Now let's go to number 2, or B. Convert the binary number 11000000 to hexadecimal. Now we are going to take a different step in converting the same number to hexadecimal. Alright, so what we're going to do typically is to count the number of values here. We have like 8 values. Alright, so 8 zeros and ones combination. Now the kind of table we are going to draw now is going to have up to 4 entries. So in that case, we are making use of half of a byte, sorry, which is a nibble. All right. So and of course the place values from 1, 2, 4, and 8. Okay. So here at this point, I will place my values. Always start placing your values from right to left. So you can see I have zeros, multiple zeros from the right to the left. Okay, so I'm going to begin here and place my 0, 0, 0, 0. All right, so I'm left with how many zeros do I have? 1, 2, 3, 4, 5, 6. So I have 6 zeros and 2 ones, reading from the right to the left. So I have placed the 4 zeros from the right. So to go over to the next one, I have to draw another table of 2 rows and 4 columns. So repeating the same place values convention, and I will start placing my 0, 0, then 1 and 1. Now, as usual, it's important I have to tell you that hexadecimal numbers are numbers that range from 0 to 9 and A to F. So in that case, all the numbers add up to be 16 digits numbers. Alright, so that's how we are going to work on this. Now, for each value in hexadecimal, there is always a corresponding decimal value, which is from 0 to 9 correspond to the 0 to 9 equivalent in denarii. Alright, then from A to F correspond to 10, 11, 12, 13, 14, and 15 in denarii, respectively. Okay, so we are going to deal with this one step at a time. For these whole things here now, you can see that we do not have any 1 here on the second row. So in that case, everything is typically 0. So we have 0 here. Everything is 0. Okay. So now for this here, where exactly do I have ones? I have 1 here and the corresponding value is 8. So 8 is written down, 1 here, corresponding value is 4. 4 is written down, the rest are 0. So I will have to add them up. 8 plus 4 is 12. Recall that 12 denarii is C because 10 is A, 11 is B, and 12 is C. So I have C at this particular point. You're not going to write 12 here because we do not have any number or any digit as 12 in hexadecimal. So the equivalent for 12 in hexadecimal is the letter C. Alright, so now I will write accordingly, beginning with the first one, which is C. Alright, then 0. Remember, this is 0 and not O. Okay. The third question converts the hexadecimal number 1A to denarii. 1A to denarii. Okay, let's work on this now. In converting our hexadecimal numbers, what we're going to do is we are going to count first how many digits of hexadecimal. We have 2 digits, so each digit of hexadecimal corresponds to 4 bits. So in that case, 1 we have 4 bits, A we have 4 bits. Then we do the conversion equivalent. So as you can see here, 1 has 1, 2, 3, 4 bits. Then A also has 1, 2, 3, 4 bits. Alright, so, and this is one, of course, I'm going to place it accordingly. Where do I have 1 in denarii? This is 1 in denarii, then the binary. I'll place 1 there to show that 1 is present. Okay, so for A is equivalent to 10. Okay, just like I told you guys earlier. Now, to place this 10 here, what I'm going to do, I'm going to look for the highest number that is less than or equal to 10. So what is the highest number here that's less than or equal to 10? 8 is the highest number less than or equal to 10. So I'll place 1 under 8 and subtract 8 from 10. So 10 minus 8 is 2. So 2 is the last digit I have now. I am going to look for the highest number that is less than or equal to 2, and that is 2, of course. So I'll place my 1 there. So as you can see, if you add this 2 up, you get your 10 back. Okay, so these 2 tables will be merged together, and the place values will be regenerated. Okay, so we'll begin with 1, 2, 4, 8, 16, 32, 64, and 128. Notice that you must do this first one first and this one differently before you can merge the 2 tables together so that you get the appropriate answer. Okay, so now having done this, I will look for, just like I would normally do, I will look for where I have 1 on the second row and bring the values on board. So let me begin from left to right this time around. I do not have any 1 here, no 1 here, no 1 here. There is a 1 here and the value is 16. So 16 plus another 1 here, the value is 8 plus 8 plus, we don't have 1, we have 1 here, then 2. All together gives me 26. Okay. For the D part of number 1, binary numbers can be stored as bytes. State how many bits are in 2 bytes. Now, before you can state this, it's important you know that 1 byte is made up of 2 bits, and of course, a bit is a 0 or a 1, right? So a combination of zeros or ones, we that is up to like 8, gives you a byte. Okay, now half of a byte is a nibble, but we are more concerned with knowing how many bits are in 2 bytes. If 1 byte is equivalent to 8 bits, then 2 bytes should be 2 times 8, which is 16 bits. Okay, so we're done with the number 1. Let's proceed to number 2. Nadia creates a digital image for a school project. Give one example of an image format. So there are so many examples of image formats. So as you can see here, we have bitmap, which is .bmp, graphical interchange format .gif, that's the extension, portable network graphics .png, joint photographic expert group .jpg or .jpeg, scalable vector graphics .svg, tagged image file format .tif or .tiff, webp .webp, MS Windows icon .ico. So all these things mentioned here are actually various types of image formats. Okay. 2b. Describe how a digital image file is stored by a computer. So typically we are going to take this step by step. An image file is analog data. Now we have analog data and we have digital data. Computers understand only digital data, and human beings understand analog data. So in order for the computer to comprehend the analog data that's been fed into it, especially with regards to an image, okay, so being stored in the computer, these steps must be taken. An analog image file is analog data. It can be transferred to the computer using a scanner or a digital camera. The device converts the analog image into a computer-readable digital image. The image is stored as tiny dots of colors called pixels, which is short for picture elements. The pixels are recognized as bits. A pixel equals 1 bit. So that is how the computer typically stores image or images. C. Nadia compresses the digital image file before emailing it to a friend. State what is meant by data compression. Now, what do you understand by data compression? We shall state it here. Data compression is simply the manipulation of a file's bit structure for the purpose of reducing the size of the given file. I'll repeat. Data compression is the manipulation of a file's bit structure for the purpose of reducing the size of the given file. This is done by using compression algorithms to manipulate data such that repeating data is temporarily or permanently removed. Some of the benefits are less storage requirements and easy or faster file transmission over the internet. Alright, I think I shouldn't have said this earlier, but we are going to get to it again. There is no problem with that. Explain why Nadia compresses the data image file before emailing it. Why must someone choose to compress an image file before emailing it? Now let's address this question. Okay. Now the question actually revolves around the benefits of compression, which is the reason why people will choose to compress a particular file. Now, people might choose to compress a file, an image file, for any or a collection of these reasons. The first one is faster transmission over the internet. The second is low storage requirements, so you don't need to buy a high storage device, storage device with large capacity before you can be able to, save some images. It is less expensive to transmit. So technically, before you can transmit anything over the internet, you must have you must be subscribed to the internet. You must have access to the internet, and this access you have to the internet is being guaranteed by an ISP, which you have to pay in order to give you such access. So if you need to transfer multiple images or images that are large in size, you can imagine you are spending a whole lot of money in doing so. So typically it's less expensive to transmit over the internet. Okay. 3. Nadia's email service uses parity bits as a method of error detection during the transmission of data. Describe how the parity bits are used to detect errors. Okay, parity bit. Let's talk about parity bit just quickly. Now, parity bit makes use of even and odd parity. Okay, before I just explain this further, let me walk you through what I have here as an immediate response. Data is sent in bytes, and of course, a byte is a group of 8 bits. Each byte contains 7 data bits. Now take note of this. Each byte contains 7 data bits and 1 parity bit. Okay, now parity checks can be either even or odd. So there is an odd parity and there is an even parity. So it depends on whichever one that the device has actually decided to use, or that's been decided to use on a particular device. Whenever data transmission is established between two devices, the sending device sends parity information alongside the data to the receiving device. Okay, now on reaching the destination device, the device calculates the total number of 1 bits and compares with the type of parity bit, parity check, whether it's even or odd. Now let me just explain this quickly. Okay, now whenever a device is to send any kind of information, it sends this information in bits, of course, and the bits that send information in comes with both the information itself and some kind of metadata about the parity bit. So whether it's using odd parity or even parity. Okay, so that's what is meant by this first point, sending data alongside the data to the receiving device. So on getting to the destination device, alright, the device calculates the total number of ones. Meanwhile, before this is done, the parity bits are actually given the information as to whether they are odd or even have been sent alongside the data. So on reaching the destination device, the device calculates the total number of 1 bits. So what do we mean by this? Now all the bits that are ones, remember we have either 0 or a 1 bit. So only the bits that are 1 that will be counted. So now when the bits have been counted, alright, it will be calculated and be classified as either even or odd. So if the received data passes the parity check, so the computer compares this particular class of the parity bit you have calculated with what it has been sent to it from the sending device, so as to whether it is even or odd. If the received device passes the check, then the data is transmitted correctly. Otherwise, an error has occurred and there might be a request for a resend of that kind of data. Four, identify and describe one other method of error detection and used during the transmission of data. Now, there are different error detections you can think of, identify and describe. So we are going to identify just a good number of them. We just need to identify one, but we identify a couple of them, about 3 of them for you, so you have options to choose from. So aside parity check as an error detection technique, there are still other error detection techniques. So the first one is the checksum. The second is check digits. They are not the same thing, and automatic repeat request. So let's go through this one after the other. Before data transmission, the number of bits is counted. The number of bits is counted. The value is transmitted along with the data to the receiving device. So the receiving device counts the bits in the received device and compares with the counted value sent by the originating device. A transmission is considered to be successful if there is a match in these values. So technically, both the sending device and the receiving device actually communicate the whether the information sent is error-free or has some kind of errors using counting of bits. So the sending device will first calculate the bits that make up the data to be sent, alright? And of course, it sends this information alongside the data itself to the receiving device. Now, on getting to the receiving device recounts and compares. Remember, it recounts the values and also compares. If the values are the same, then there is no error. Otherwise, both systems will know that an error in transmission has occurred, and there might be a necessary action to request that data be resent to the destination device from the originating device. Okay, for the check digit, it is used to detect human errors when entering such identification numbers as barcodes, ISBNs, and bank account numbers. So the digits in these identification numbers are used to perform a calculation to produce a check digit. Now, it's important you know that there is a difference between checksum and check digits. While checksum counts the bits that make up data that has been sent, check digit uses such identification numbers as ISBNs, barcodes to actually do the calculation. So they don't do their calculation using bits, but they do their calculation using identification numbers on such numbers as barcodes, ISBNs, and bank account numbers. And this error detection technique is used when data is being entered into the computer. Okay, now the check digit is added to the end of the number. Once such number is entered into the computer performs the same calculation and compares the value gotten with the check digit. Okay, so it's important to know that the check digit has already been programmed into the computer or into a given system to check whether the digit is correct or not. So on entry of any particular digit or number of digits, what the system will flag is whether there is a kind of mismatch with regards to the digits that have been entered based on its calculation. So once all the digits have been entered, and the system will calculate the numbers and compares with the preset check digit that is already stored in the system. So if there is any error, the entered number is or might be rechecked, and a re-entering may occur. Automatic repeat request, which is also given the acronym of automatic repeat request, is a repeated request sent from a destination device to the originating device. Okay, and this is usually given the acronym of ARQ. Right, so it occurs when there is an error in a given packet being transmitted. The receiving device keeps on sending a request to the originating device in order for the correct packet to be sent. So if some data is sent to a particular device, okay, and this device senses that this data is incorrect, it continues to request a number of times as long as it is incorrect until the correct data is actually sent. Now it's important, some of you might be asking a question, how is the computer going to know that the data to be sent is incorrect? It will know using a combination of other error detection techniques. So definitely when other error detection techniques are being used and there is a kind of error flag from the receiving device that a couple of data that's been sent is not actually correct, then the repeat request, a repetitive request, will be, we keep recurring until the right data is sent. So definitely this is how it does it, because it can't just know it without having some kind of mechanisms. Okay, so we are done with identification of some error detection techniques. Now tick to show which logic gates will give an output of 1 for the given inputs A and B. Let's work on this. This is actually logic gates, right? And there are rules guiding logic gates. let's begin with and we saw everything about AND gate. The AND gate is such a logic gate that accepts two inputs, and the output can only be one when all the inputs are 1. So as you can see here, A is 1, B is 1. Therefore, the output is 1. Otherwise, it is 0. So if any of the inputs, if all the inputs are 0, it is 0. The output is 0. If any of the inputs is 0, the output is also 0. It can only be 1 when both inputs are 1. As you can see, A is 1 and B is 1 here. Alright, now the OR gate. The OR gate, the simplest rule guiding the OR gate is that both inputs must be 0 before the output is 0. Now where do we have both inputs 0? We have A 0 here, B 0. So in that case, for the OR, output is going to give us 0. Otherwise, every other thing becomes 1, as you can see here. Alright, now the NAND gate is an opposite of the OR gate. So since we already have AND gate here, okay, so the AND gate, the NAND gate, the simplest rule, just to make sure that we are systematic, is that the output is 0 when both inputs are 1. So you can see both inputs are 1 and the output is 0. So every other thing becomes 1. Remember, it is a negation of the AND gate. So if you take it in that manner, you'll notice that 1 here changes to 0, 0 changes to 1, and 0 changes to 1. The NOR gate is just the direct opposite of the OR gate. Okay, and the simplest rule here is that the output is 1 when both inputs are 0. So as you can see here, so you can also take your OR gate rule and apply it here in the negative way. So 1 changes to 0, 0 changes to 1, 1 changes to 0. The XOR gate, which is also called exclusive OR gate. Exclusive OR gate is always in such a way that the output is 1 when any of the inputs is 1. So in that case, if you have all the inputs to be 1, it is going to give you 0. And if you have both inputs 0, it will give you 0. It can only be 1 when any of the input is 1, but not both of them. Okay, so as you can see, it's only A that is 1 here, B is 0, and of course we have 1. Draw the logic circuits for the given logic statement. X equals A XOR B and B or not C. So we have to take this bit by bit. We take this A XOR B using the appropriate logic gates. Okay, now here we have A XOR B. This is how the gates of XOR looks like. Okay, and the next one we are going to take is B or not C. So this is B coming from here again, or this is an OR gate. Alright, then C, this is the NOT of C going to this point. So we have terminated here. So in that case we have A XOR B here. Alright, and we also have B or not C. Now, what are we representing? We are representing the whole thing using an AND gate. So we have to join A, X, or B, and B or not C using the AND gates. Okay, so we have this joined using the AND gate to give us our output X. I hope this is okay. Okay. Pradeep uses his personal computer to complete work at home. Pradeep uses a mouse and a keyboard to control the computer. Complete the description of the principles of operation of a mouse and any keyboard using the most appropriate terms from the list. Not all terms in the list need to be used. So what I'm going to do here, I'm going to just walk you through just quickly how this is done using the appropriate. Now, anywhere you see the bold text, it shows you the actual response to the blank spaces here. So it shows you the actual response. An optical mouse shines a red light from a LED, and LED means light emitting diode. So let's just read from here anyways. An optical mouse shines a red light from a light emitting diode underneath the mouse. The light reflects, this is another option, back from a surface through a lens in the mouse and is converted to a value. This value is transmitted to the computer. The computer then determines the speed and direction of the movement. When the user presses a key on a keyboard, the key pushes the switch on the circuit board. This completes a circuit. Signals are sent to the computer. The computer uses the data to calculate which key was pressed. So that's typically what this is all about. Identify two other input devices Pradeep could use with his personal computer. So aside the mouse and the keyboard that have been mentioned here, right here, as you can see, all right, there are also other input devices, and you've been requested to just like list two of them. So I've listed a couple of other input devices here, like tracker ball, touchpad, joystick, light pen or stylus, scanner, cameras, microphone, and sensors. So all these things are options you can actually choose from. Any one of these should take you to the correct answer. Pradeep uses a projector attached to the ceiling at his home to watch high-definition films. The projector has broken. He wants to buy a replacement. He needs to choose between an LCD projector and a digital light projector. Explain why an LCD projector would be more appropriate for Pradeep. So it's more like comparing an LCD projector with a digital light projector. So let's look at the differences and the comparisons. Now, advantages of LCD, which is liquid crystal display, over DLP. DLP stands for digital light projector. So you might also have to know some of these acronyms just for cognizance sake. Now, the advantages of LCD over DLP include the following: less energy requirements, that means it doesn't consume much electricity, anti-glare as it controls excessive brightness that could damage the eyes. So it means that it actually controls so much brightness that you could have experienced using DLP. So DLP is too bright and can damage the eyes and even cause headaches when it flickers. So less heat emission, because it makes use of quite small amount of electricity. It tends to emit less heat. It produces sharper image and also better picture quality. So these are the reasons you might choose LCD over DLP projectors. C. Pradeep stores his collection of films and his work files on his personal computer. Pradeep wants to save a copy of all his films and files onto a single storage device. Identify and justify a proper storage device to store the copies. Now, take note of this. He stores his collection of films and his work files on his personal computer, but he wants to save a copy of his films and files onto a single storage. So in that case, he needs a backup storage to save this. And for him to need such backup storage, we wouldn't know the kinds of things, the amount of storage required, but obviously from what has been pointed out here, he might be needing something that has an appreciable size, large size. So in that case, size is actually something that must be considered, or rather the capacity of the storage device has to be considered here. So it is something we have to consider, which of the storage devices will be used to store something that is actually large, and besides that, not too expensive. So let's look at the answers here. Now, storage device to be used will be portable hard disk drives. So portable hard disk drives. And why must we use a portable hard disk drive? One is that it has large memory capacity, fast data transfer rate, fast data access time, and easy to transfer data from one computer to another. So these are the reasons why we have to choose that. A holiday company has a website where customers can create accounts and can book and pay for holidays. The website is written in hypertext markup language. Give 2 examples of HTML structure and 2 examples of HTML presentation. So now technically it's asking us to give examples of HTML tags that are being used to design a web page, as well as CSS, which are used for presentation. It's important I let you know here that in any given website, you must have a structure and of course you must have a style. The structure deals with the layout of the elements or the contents of the web page, and the style, the presentation deals with the style or aesthetics, the beauty of the website, just like the color and some kind of visual effects that add spices to your web page. So, and what we use for structuring a website is simply HTML tags, while what we use for designing or taking care of the styles, beautifying the web page, is CSS, which stands for Cascading Style Sheet. So we have two structures that I have actually given here. Structure 1, you have, this is H1 tag. Now, as you can see here, I began with the H1 is enclosed in an angular bracket, that is this less than sign and greater than sign, covering H1, and H1 is actually a heading level 1. There are 6 heading levels, so any one of them you choose is correct. H1, H2 up to H6. So H1 has the largest font size. So, and we are going to actually close our tag here using the same angular bracket, but before the H1 is written, we have to place our / here. Alright, so this is a P tag. P tag is for paragraph. So you want to create a paragraph in a web page, you have to make use of this. By the way, for some of you that might be needing to know this, you might not necessarily be writing your major examination now, but for subsequent examinations, if you think you need this, I think you have to make sure you click on the subscription button and also notification bell, so that you will be able to be notified whenever we upload videos on HTML and CSS. So it's actually very important. So this is another tag, which is body tag, and we close it here. Any tag we open, we tend to close. So it's important to take note of all the tags. There are a lot of tags. So this is HTML root tag, and of course this is title tag. Alright, opening and close. There are so many other tags you can think of. In a presentation, we make use of what is called selectors. So in this case now, the selector here is the body selector. Why is it a body selector? This body selector comes from the tag that is in the body. Alright, that's the body tag. But in this case, we do not enclose it within angular brackets. So it's just standing on its own. Then you open a curly brace. Okay. Now this usually has a property value pair of properties. Okay, so you want to assign a background color to the body of your web page. Now you make use of this background -color (blue). Then you close your statement with the semicolon. Alright, so, and of course our curly brace closes here. So the curly brace begins here, right, and it actually closes up here. So in that case, I just declared a single property for the body. The property is background color, which is blue. Now the differentiating thing between the property and the value is a colon, and at the end you have a semicolon. So very important. Now we take a look at another one, like H1 is also an element selector, okay, because it refers to H1, which is a tag in HTML. So you have font -size, which is a property, and of course the separator, and then the value 18 pixels. So pixels in CSS is written as px and not spelled in full. So it's very necessary you get to understand that. So there are so many other things you can actually do. You can also try on assigning a different property to the p tag. Okay, so the property could be the color of the text, which is normally used as color, COLOR. American spelling for color is used. Then you can now just write something like black or red. So 81 of these should be okay and should get you to what you're looking for. B. The website is stored on a web page. Customers use their own computers to access the website. Uniform Resource Locator, Internet Protocol, and Media Access Control are three types of addresses used by computers when accessing the internet. Give two features of each address in the table. Okay, so we are going to give features of URL, IP, and MAC. Alright, so here are the features. For URL, it's a website address. Okay, just like you have a www.cambridge.com. Alright, it is made up of access protocols. So access protocols in this case are HTTP or HTTPS and a domain name. So it's made up of these two, both HTTP as well as a domain name. Domain name is a name, the actual name of the website. So this is the protocol on which the website runs. So it comes before the domain name. Alright, so it is used to access a website on the browser. So you can actually type in the URL on address bar of any given browser, and it will take you directly to the website. So this is usually ideal so that you can escape certain security risk as phishing and pharming. Alright, so if you know the website address of the website you are going to, there's no point using search engine to actually take care of that. You can actually type in the address on the address bar, and it will take you direct to the website. So it is used to access websites on the browser. It is translated into an IP address by the domain name server. So URL can be translated into an IP address because it represents a server, just like a website that is stored in a given computer remotely. So for you to access it, you must access the network address, which is the IP address. An IP address, a unique address assigned to a specific computer in a network. It identifies the location of a device in a network. It consists of 32 bits. It is divided into 4 portions of 8 bits. Each portion is equivalent to a binary value between the range of 0 to 255 inclusive. It can be assigned to devices statically or dynamically. It is assigned by an ISP. ISP stands for Internet Service Provider. Sorry, excuse me. IP addresses can be changed. So technically they can be changed. It's important you take note of this. They can be changed. Okay. Now, a MAC address. It is a unique address that identifies a specific device in a computer in a network. It is assigned by the device manufacturer. Remember, this one is assigned by the ISP. IP is assigned by the ISP, and the MAC is assigned by a device manufacturer. It cannot be changed, but IP can be changed. It is written as a string of hexadecimal values. A MAC address is equivalent to 48 bits, so this is equivalent to 32 bits. Okay, C. The company is concerned about threats to its web server. Complete the table by identifying two potential threats to web server, the impact each threat could have on the company, software the company can use to help to limit each threat. Okay, now in a given web server, it's obvious that such web servers are prone to threats too. So we need to identify such threats and some certain things these threats can cause, as well as the software that will be appropriate to get rid of such threats or to control such threats. Okay, now one of the threats we have is denial of service attack. This is a situation whereby a malware infested computer sends multiple requests to the web server beyond what the server can handle. So when numerous requests flood a particular web server, there tends to be a kind of breakdown on the server. Okay, so and it becomes unable to reply any request at all because you are more like getting the server confused. Okay, so and the software that can be used to control this is firewalls, where you can also make use of proxy server. Proxy server can intermediate between the server, the read server, and such requests. So it does the work of taking care of such numerous requests that tend to flood the web server, so that it wouldn't get to the web server itself, and at the same time the web server is still accessible to everybody that uses it. So just that's what a proxy server does, and firewall can actually store this kind of actions by warding off some kind of requests from certain devices, malware or virus. And this particular threat comes by installation of certain malicious software, which includes malware and virus. Okay, and when this type of software is installed in a computer, it tends to actually corrupt the files and also makes the system to malfunction. And one of the things that can be used, or one of the software packages that can be used to stop this, is anti-malware or antivirus. Okay, so at this point we come to the end of this lesson, or this tips or question and answering of February-March 2022 IGCSE Computer Science. So you should be looking forward to our video. So before you log out of YouTube, I urge you to click the notification button, as well as the subscription button, as well as the notification bell, just to be on track of what is ahead, because we shall be publishing videos on the problem solving, which will be very, very crucial, especially for those of you writing May, June IGCSE, because you are here to write that. So we are going to deal with series of questions regarding problem solving. So see you in our next video. Bye.